sponsoring us tonight. With that, I will turn it over to our speaker, Jeremy Anderson from Cody.
Thank you. All right. I'm going to do this with minimal mic jangling. Nice to meet you, everyone. So tonight's talk is on software composition. If you haven't heard of this, it's become an area of panic for me. So I'm responsible for application security, the entire program at Cambia. So I'll give you a little bit background about myself and then why I'm freaking out over software composition and what I'm doing to try to address the problem. And try to answer as many questions as possible along the way. Happy to have this be as dynamic as you like. So if you want to stop me and ask questions in the middle, feel free to do that. That will certainly define, I think, a bit on how long this takes, but hey, that's up to you. So a bit about myself. So I've been a software developer. I came to InfoSec by an odd route. Most InfoSec guys, at least the ones that I've met, have been primarily ops guys, come up through the server operations and identity management ranks. But I came to this primarily as a software developer. I first started writing Perl back in the late 90s. Current bit of a polyglot. I've written mostly web content management based. Web applications, current language count about 8, primarily web-based languages. Toughest job ever was a couple of jobs back. I managed the wholesale banking platform at US Bank. I was there 7 years, and so it's basically, if you're not familiar with what a wholesale banking platform does, basically processes check payments. So when you send your Northwest National bill in, it actually goes to US Bank, actually the back door of the US Bank building here off the 84. They rip open those checks, run them through a scanner, and Northwest National gets their money in 4 hours. So that's kind of a really cool thing. Basically, process $3 billion a month in those check payments. 9 operation centers running in 24/7 shifts around the clock. We had 45 servers and times 2 if you count our disaster recovery process. But we actually didn't have disaster recovery when we first started. I inherited the platform with 0 disaster recovery ability for $3 billion a month check processing. Yes, I was totally freaked by that. So you might wonder how I got into application security. Well, the InfoSec team came to me after PCI became a big thing and dropped a tome on my desk and said, here's 300 pages worth of vulns. And they had just gotten a new tool, right, their new thing, and they ran it and spit something out to tell me that I had over 1,100 security defects. How do I fix these? I don't know. You're the software developers. You guys figure it out, right? All right. Well, where do I start? I don't know. They're all the highest priority. Every single thing has to be fixed. Right? So somebody else has been through this before, right? And then, okay, well, I'll put it in my product backlog and we'll get after it. Nope. You got 30 days to resolve this, or you're going to go on a report to the CEO that will stay on that until you get them all fixed. So it was like, no, this is not okay. I put on my Batman mask and went down into my lair and emerged after some time as a champion for secure code justice. So it's no laughing matter to me when I call myself a secure code monkey. I really have been a code monkey for a long time, but getting developers to be concerned about code before they try to ship it is really the name of the game. And so that's where this particular area comes into play. Many of us likely have static analysis tools that we use on a regular basis to analyze developers' code, things like check marks or Fortify or what have you. We're also likely doing dynamic analysis in many cases. You've got your Qualys, you've got your what have you. And then endpoint protection, right? We're always making sure that what we're running on the servers is the right thing and it's not out of date or vulnerable. But what about what's inside our software? So I started to ask this question when I first started at Cambia. Hey, we're shipping the software, but I noticed that a lot of what we're shipping is not just our code, because developers told me, well, how much of this code is ours, how much is theirs? I don't know. And it also had an effect on our licenses for static analysis, because the particular vendor, licensed by number of lines of code or per megabyte or whatever you would have you. Well, then how do you argue what is your code versus what's someone else's code, right? So you got to kind of figure that thing out. So a couple of kind of scary examples from the tinfoil hat crowd to kind of get you thinking about what this concept looks like, right? So anybody ever eat a chicken nugget? Maybe. A bit of a guilty pleasure. This is kind of the opposite direction. Most of this is likely, perhaps, at least a high percentage of meat. But what might be hiding inside your chicken nugget? Well, some scary sources say that there's an element in there, or an ingredient, tertiary butyl hydroxyquinine, which is either sprayed directly on the chicken nuggets or inside of the box to make it seem fresh. And that's actually butane. So think Zippo lighter fuel. That's disgusting. Maybe a little bit less disgusting. Perhaps not. So this is some slow-churned ice cream, right? Mostly milk, mostly sugar, mostly eggs, those kinds of things. But they, to get that creamy but not too hard sort of feel, maybe a little bit of antifreeze, propylene glycol. Oh, wow. All right, one more, just because this is fun, and what we couldn't do without Shack sodas, right? So if we're looking across the spectrum, especially of your non-organic touting sodas, they're certainly not in LaCroix or Hansen's, but perhaps in Shack. There's an ingredient called vanillin. It's actually synthetically created vanilla flavor. And they also use it to kind of keep things in suspension so that it doesn't get separated. It's most commonly made from precursors found in the production of petrochemicals. So, yay. So this is actually kind of the opposite direction, right? So we're thinking, maybe 98% of our thing is not too bad for you, but there might be some small amount of stuff in there. But what if we're looking at this in the other direction? So this is just the code that you wrote. 5 building blocks of awesome, right? You're going to ship this new functionality. It's fantastic. You wrote something great, and I came across my developers consistently. After we found a solution to identify our open source stuff, I started scanning, and upwards of 95%. I'm not talking 95% or less. 95, 97 is about the range of open source components packaged in together to create a shippable build for our apps. So if what we're shipping is 300 megabytes and what we're scanning in our static analysis tools is more like 1.5 megabytes, what does the rest of the picture of my app look like? What's really in there, and how do I find out about it? So if this is really more like what the picture of that looks like. If you think 5 out of 100, 5% of my app, the rest of that is your actual attack surface. That's what attackers are literally pointing their guns at to try to identify weaknesses in your apps. Right? So, and it could be, some of the problems that I came up, that I was trying to solve is the, when I do identify that there's a problem with a particular library, how do I go find out where I have it? What do we do today? And then, if I do know that particular teams are using, say, struts or Ruby on Rails or particular gems from Ruby, the Ruby packages, or particular items from the Node package management, what version are they using? When was it last updated? How old is it? So maintaining freshness, finding out about known vulnerabilities in those libraries, all of these are concerns that I have. And then the last one, I got particularly freaked out last year when VMware got sued because they were including in their code base and in what they delivered part of the Linux kernel, which was covered by a GPL license, which happens to be copyleft. And if you're not familiar with a copyleft license, it essentially says if you're going to ship something, you have to tell everybody that you use this open source thing, and you have to make your thing open source. That could be a concern when you're shipping commercial software and charging for it. So you start to try to address this problem, and how do you find those vulnerabilities? And this is kind of thinking back the other direction. So recently we had this problem come up. Anybody have web apps in their portfolio that use struts? Anyone? A couple of us at least, right? Recently there was a remote code execution vulnerability found in certain versions of struts. And so in order for us to identify where we might have those versions, we had to first run an ADDM scan, which was essentially looking for a published announcement basically of our pipeline telling us that we have this thing. But the particular engineer, in his brilliance, was like, I don't think I really trust this scan result. I don't think they really probably found everything. Let me run something else. And so we ran Symantec's vuln management tool also against it. It took another 32 hours for that to run. And it scanned for basically looking in all of our systems, where do we have both Apache and struts? So where this condition would be exposed. That was better. We had more complete results, but still, it still took us over 2 days to get results. And then tracking mitigations on those is even longer, right? So how do you take every instance of that, go back to the developer and ops and get them to patch this, update their version of struts, wait, we can't update that version of struts because it'll break everything. And then actually the more embarrassing thing for us was finding out that, yes, we have struts, no, we're not exposed, and the reason we're not exposed is because our struts version is so old. Versions, didn't yet have this published. So, thankfully we have that great firewall that's going to protect us against these particular types of strings, but that might be used in the attack, but still a huge challenge. I mentioned the legal risk. So some of the solutions that can be used. The first one, host-based agents. That's great if you have a solution that does that. So something that lives on the host essentially can scan the host looking for things that might be a problem and quickly provide you with a picture of what's in your inventory. This could be a con because it's, of course, in many cases going to miss items that are in a compiled binary, right? So you don't necessarily know what's in that thing that's on your thing, but you might know all the things that are out there, but not necessarily what's inside of them. And you still have to know what to look for. So when you run a scan, you're going to kind of, each time you have a new vulnerability disclosure, you're going to go out and scan your stuff and look where you have things. So you still have some challenges with that. The other thing, the better solution, I think, is having tools that actually analyze the composition of the software that you're deploying. And this is the direction that we went. So essentially, during our software development lifecycle, my whole mantra is shift left as far possible as I can, getting information into the hands of my developers when they're writing code at dev time, versus when they're trying to deploy code at prod time. So it's essentially the information that we have is fresh as of the last deployment. So if our developers are deploying weekly, then we have fresh information that's weekly, and if we can ensure that they're not bypassing our process, then and deploying outside of the build pipeline, then we know that the information that we have is good. So essentially, it provides information about what we have in the build. So the solution that we chose, I'll actually get to that in a second. So the cons to this is, YAT, yet another tool, right? So always a bit of a culture problem getting developers to accept the results of some new thing. It's tough enough to get them to accept the results and mitigate items from the stuff we already have, right? So adoption here has been a challenge. I'm an army of one against 250 developers at Cambia, protecting upwards of 35 applications, various sizes and scopes. Scaling my program is certainly the biggest challenge, and the way that I go about that is primarily through making friends and influencing people, getting developers on my side, and letting them do a bit of the automation as well. So we looked at a few tools in this space. Some of these are names you've probably heard of before. Black Duck is probably a familiar one. Sonatype's Nexus platform, which is actually kind of a multiple pieces, so they have a repository of good things that you can have developers access that actually proxies and stops requests that go out to GitHub and instead routes them into Nexus, which is kind of neat. And they also have a scanning engine that plugs into your pipeline and will scan on demand. They're ferociously expensive, so that wasn't the direction that we went. White Source is similar. The challenge with them was getting something that would integrate well into our build process. They weren't as advanced as we had hoped that they would be, or easy in that regard. And in my conversations with the analyst types, they weren't as impressed with what's happened with Black Duck. They just haven't kept up with technology pace. So the idea here is not all players are the same. For us, language support was key. As you can probably guess, because I've shot down the others, we went with source clear. Freshness of data was really important for us, and so their solution was interesting because they were fairly inexpensive. So they were a couple-year-old startup, so they're still pricing things at a pretty nice entry-level spot. So you can get their solution really cheap. When I want a new feature, they have been implementing what I asked for, which is really nice. So that's another benefit of small guys. And then they have a team, they're big on data science, so they have a team that's actually scanning your open source repos, like SourceForge and GitHub, et cetera, NPM, and looking for things that might be a flaw that's not yet published in the SCDE. So if a developer checks in a piece of code and says, hey, I fixed a cross-site scripting vulnerability in this, blah, 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 they flag that, and it gets human reviewed nightly by a team in Singapore, and they actually are validating these things, which I found really interesting. So it's a lightweight command line interface that runs on the build server during the build process, reads the package JSON file, an NPM or a node package, or the POM XML in the case of a Maven output for Java, so et cetera, et cetera. They covered our core languages, which are Java, Ruby, Node, and Python, and they worked well with all those, so they were the one that we went with. Easy deployment, yeah, it was really easy. They also have a public process for me coming into the InfoSec world, because there's something unique about this build process, and it actually looks similar in dev as it does to prod. And there's one key difference, and I didn't actually Actually, I do have it in there. I could actually show it. But the key here is that on our way to building and putting out in a development environment, we're running these checks. But we're doing our checks and our builds at the same time, and it's asynchronous. So we're not stopping to see what the status of that build was before we deploy. This is a huge DevOps-y mindset sort of change for us, because the normal posture for InfoSec is, if I find something, stop, right? Well, when your scans, especially in the case of a static scan, takes like 4 hours plus, you can't stop, right? Developers are trying to deploy over 11 minutes in a lot of cases, so we got to keep moving. So we run these things asynchronously, and essentially what we're looking for is we give them warnings early and often in development, so developers are constantly in the mindset of, hey, I'm looking to fix vulnerabilities as we see them found. And they're fixing things in each of their sprints such that when they do deploy, we're asking the question of the policy engine, what was the state of the last completed build, because it takes so long. If the last completed build was a pass, then they keep going. If the last completed build was a fail, then they need to tell us why they're able to deploy and how they fix things. So that's a bit of a piece there. We're actually, in this warn versus fail mindset is kind of pervasive in our process right now. So instead of failing and halting deployments, we're warning and looking for good citizens instead of good builds. So that's kind of an interesting process. It's only been in place about 6 months now. So, and so far the developers that we have in this automated build pipeline are performing well. So they have really high scores of resolving defects really quickly. They're glad to have a tool that gives them fresh information instead of something that they have to ask me to go run, and I run it 5 days later and get a report and I'm really mad and those sorts of things. They're like, 2 days before production, and that's generally the scenario we've been in. So this has actually been a really helpful change for them. So some of the key takeaways. The first one is automate everything. When I was interviewing for my role, I knew I would be, I asked how many developers in the organization, like 250, I don't know how many apps, are in the portfolio. We don't know. They didn't have an app inventory, and they couldn't tell me the scope of my job even, so I'm like, this is gonna be bad. So I knew as an army of one that I could never scale the program by myself unless I automate the shit out of everything. So my first hire was for Python programmer, AppSec engineer to help me script everything I can and help the development teams write these things into their pipelines so that we can scan continuously and address things that hit the highest. Publishing those results automatically has been key as well, making sure that we're sending it to developers constantly, so they're getting the output of the tool consistently. The next one is collaboration is key. So I involved development teams early on, especially the high-functioning development teams, in the process of tool selection. So they were involved in assessing what we saw in the market from the vendors that we looked at, which one they thought would work best, running some pilots against their tools. That's when I had my first freak out, because we ran a 300 megabyte Ruby app through the tool, and it said that 3% of it was custom code, and I'm like, a big gasp of air. So that was interesting, and I went to my CISO, and he had an equal freak out. So that was fun. I asked for help from our automations teams as well, because we still have our operations teams responsible for our build pipeline tools. So they were helpful getting the scripts that we wrote and the call outs to these third-party tools baked into Jenkins and baked into GitLab CI, so that on each new build, just like a GitLab CI would run a RSpec or something against a Ruby app, it automatically runs, kicks off the scans for these tools as well. And then the most difficult thing is the thing that we haven't figured out yet. Legal has been a huge challenge, because while our legal team understands the nature of a copyleft provision in an open source license, they don't know what to do with the volume of licenses that we have. So I was able to figure out, based on what we've been deploying, hey, we have 18 different licenses in use, and aside from the you can do whatever the F you want license, I'm pretty sure the rest of these might have some concerns. So I gave them that list, and they still haven't given me a matrix of which ones are okay or should be blacklisted. So we're still waiting from that. So start early. You'll need a lot of help getting your legal teams on board. And then communicate. You know, I've been actually sharing these same sorts of freak out stories with our development team so that they understand why we're doing this. I think giving them some of the background, talking about what happened with VMware, or how long it takes us to find struts on our 50+ servers. Those are some challenges, right? So getting them, like, if we had you in the build pipeline for this tool out of the gate, you would have known that your struts was 7 years out of date, and you would have fixed it a long time ago. So, you know, just getting them on board was really key. And with that, happy to take some questions or what have you. Yes?
Yeah, I was wondering, can you speak if there's any experience there with working with various dev teams about any kind of feedback loops that you're able to work with to help them learn such that they don't have to stop them?
Yeah.
Such that, you know, they're able to really understand the technical details of what the problem is, learn from it, and not do it again.
Yeah, absolutely. So the question is around how do we get devs to not create the same defects over and over again by actually learning, and that is the key piece of the program that I'm building is training. So we're investing in our budget a line item for training the company's developers. So I earmarked I think $100,000 this year to train developers, and got it. Nobody argued that developers need training. So that is a key piece, but that's an ongoing effort. The other piece is developing a champions program. So eliciting the help of all of representatives from each development organization to get specialized one-on-one training and participate in consulting efforts with their teams so that when defects come in that they're unsure about, we actually discuss those defects, how they can actually be exploited and why they're a problem, and then not only that, but how to resolve them. So for me, fix versus find is huge. So finding a bunch of vulnerabilities obviously wasn't really helpful for me in my experience at US Bank. Showing them how to do it better, and I like to constantly poke at the OWASP top 2, that's what I call it, cross-site scripting and SQL injection. Why they still exist is beyond me. It's primarily, I think, because our universities still have security as an elective, as opposed to being required. So, you know, showing a developer how to wrap an input in a code string is like so simple, or use a library that does that automatically. Some of your front-end frameworks like React or Blueprint or Pancake or Handlebars, you go down the list, right? They all do these things out of the gate now, better at least than they used to. You know, I think if you can get the health and hygiene aspect of things into developers' mindsets early, then they start to understand that's a problem and help and design things in a better way. And so doing threat modeling with them at a very high level, threat modeling light, we call it. Just what are you trying to do? What are you going to put in there? Who's going to look at it? Just your basic questions. Just doing that at DevOps speed is the biggest challenge for us right now. So that was a long answer to the question.
Do you find that they are able to understand security from a basic perspective, like an attack surface?
Yes. And it's still through demonstration. So we demonstrate exploits. That's pretty compelling.
Is there anything involved in the training as far as the developer discovers a vulnerability in a library they're using and how to actually report that kind of thing?
So the answer is, or the question is there anything in the training related to
Reporting, vulnerabilities and open
reporting
source software.
vulnerabilities
Yeah.
in software, so in third-party software?
Yeah, yeah.
So no, we don't really talk to them about responsible disclosure per se because they're not red teamers. They don't really know that stuff well. I am starting to develop some relationships with our QA guys who are kind of interested in upping their game with that regard, and so that would be something I talk to with them. You have a question?
So can you go back to your DevOps slide?
Yeah.
So you have the source clear there, right? So from my understanding, aren't they using the source clear to figure out before using like an open source library?
Yes.
Before the fact they actually get into the code. But this is like after the fact, right?
Yeah, you're correct. So there would be a manual step at the design phase, right? So a developer should be able to go to source clear ahead of time and say, hey, I'm planning to use these 5 libraries. What's the status of these? And get an answer. If they don't do that, we're going to check it. Yeah, and everything is automated. Is kind of our goal. We're not there yet because I'm 8 months into this, but we do have 12 teams already onboarded.
So when you say everything automated, so it would automatically, before they actually introduce an open source component, it will automatically go to the source clear.
So my mindset is I don't want a developer to ever have to run a tool on their own.
Okay.
Nobody touches a portal for one of these tools. Nobody runs anything against their code on their own. Nobody has to go out and get a report. I expect that this will be built into their CI, whenever that is, and fortunately we have several. So we have Circle CI and GitLab CI and Jenkins, and I'm sure there are others that I have yet to hit, but we wrote some lightweight Python runners for each of these things that do the deployment that they can just bake into there. And like I said, they're asynchronous. There's no waiting, so it returns an exit code of hey, we're good, keep going, right? Every time, and it's in warn mode, with the exception of, and I can show you the prod pipeline. So the prod pipeline, that's it. The source clear is still, and for this entire year, is in a totally non-blocking mode. We'll never ask. We're trying to develop a culture right now of them understanding what's in their stuff, right? So a huge piece of this is I don't want to come in with a hammer. Everybody will scatter. Where the other piece of this, they're used to static code analysis and dynamic code analysis, so they are expecting that. We do have that policy check at late stages, but again, that policy check is good citizen versus good build because of how long it takes. So we're basically, are the conditions of your scans on a regular basis meeting policy? Because you had information at dev, you've known about this stuff for a long time, you should never have a critical or a high. And we have all of our policies are codified in the tool. So because we're a health organization, we have PHI data. Any externally facing PHI containing apps have to meet a higher level of stringency than an internally facing app without PHI that only is used by 10 people. It's like, yeah, I don't care. Just so yeah. So each one of those is codified, and they do various degrees of capability at resolving things so far.
So is that, I'm guessing it's automated, right? If there is a problem found in your code or something, it will automatically create a defect in your
Not yet creating defects automatically.
Okay.
So right now it's conversations. So I'm going back to the dev manager. Hey, it looks like you have some defects that are being unresolved. And right now, each of these is at various levels of requirement for them to, at the speed at which they must resolve them. So our highs and criticals have to be resolved immediately before they can deploy. But anything that's medium, low, or informational, that they have a longer period of time, right, depending upon, again, the strictness of the app. And so, if I see things not being resolved, then I'll go back to them, hey, looks like you guys are building up some debt here, what are you doing to resolve that? And in most cases, they're pretty willing to discuss remediation. And again, it comes back to, I have to discuss with them how to fix it. So it's like, I can go in and show them areas of the tool where they can analyze what they should fix first. So, hey, it looks like if you were to replace this one function in this library that's used in these 38 places, you'd resolve 38 defects. So go fix that one thing, right? So that kind of analysis is huge as well, and that's pretty effective. Yes, sir.
Any problems with false positives?
Always. That is a reality of the world we live in. And it is a constant balance of managing false positive fatigue in developers, because they're so used to, if anything was ever a false positive, everything is now a false positive as far as they're concerned. And that's where having people who are former developers or who know how to write secure code or who know how to exploit code or apps on your team can be really effective, because being able to actually go back and show them, look, I inserted this, I got this thing on the other side. We're not arguing about whether or not this is a false positive, right? Or you've hard-coded your password in your file. Like, that's not okay. Like, that's never gonna, like, here, I can look at it. I can read code, I can write code, so I can identify those kinds of things, The places where we get into arguments is, around things like insecure cryptographic algorithms or something like that. Why is MD5 not okay? So, we'll have those conversations, but, in general, if we set a policy level and we set the expectation early and we show them what's in there at development, again, it comes back to, if they're trying to deploy something and they have to wait until just before prod to ask me to run a manual scan that give them results that suck, then them getting it fixed before prod is impossible. But just giving them this information early on, built into the dev lifecycle, not to think about it, they're going to get reports and can go view defects on their app from build to build to build, see trajectory over time with flaws, flaws per megabyte decreasing, those kinds of things. Those are all becoming badges that they're, talking about between each other, like, hey, I resolved these 5 things this week, and our percentage rate went down, our score went up, also, and so that's been really good. Yes, sir.
How does source clear is running against the source code, right?
It is. So it's actually running it's running more as part of data. Yeah, this is not a huge volume, and it doesn't really change much from time to time. So the volume of information is sufficiently filtered to where they accept the signal. Works out. Yes, sir.
Do you have any mechanisms for either quantitatively or qualitatively examining how well the various tools and techniques you're using are working?
Yeah. So the question is, how do I determine whether or not the tools are working? That's a good one. So, and it's not particularly quantitative in any respect. And kind of a finger on the pulse of how developers react to the information and their willingness to adopt the tools. There's some resistance, I think, initially, which is why I go through those couple of slides about my story in the Batman mask, because once they figure out I'm a developer, I've been beating my head against this most of my life, I understand your problem, then they kind of lighten up a little bit. We talk about how we can get stuff baked in. And when I tell them, I don't expect you to write the integrations or to build anything, and if it doesn't work the way you need it to, I'll go fix it. I've done. We work this next stuff out. So that's my answer for everything. Used to be Perl was my answer for everything. Now it's Python. All right, we're at quarter past the hour. I think that's a wrap. Thank you again, everyone, for having me and for listening up.
Thanks, guys. We're looking for future speakers. So if you have a story to tell, your experience on the share, shoot me an email and we'll try to arrange something for you for the time slot. And like I said, our next meeting will be on April 2nd and we'll have a discussion. Thank you very much.